So let's talk about next step. There's also the option to perform analysis with EDRs and Velociraptor before we dive deeper into forensics. And here is the thing, Velociraptor is not a classic standard EDR. This is what I just wanted to talk about in a little bit. Now, EDR is basically endpoint detection and response. Yeah, people are actually asking for the course. Thank you for posting those links in there. I appreciate it. You can also go to bluecapesecurity.com/courses and find all the courses that are out there right now. And like I said, there's more to come. Now, what's your favorite EDR? Who is using EDR in their environment? Just want to see what you guys are familiar with. I would assume CrowdStrike and Sentinel is probably the top two as always. Oh, there's someone on Carbon Black. Nice. I'm so glad I got Carbon Black logo on my slides here still. It was more like for sentimental reasons, but still. Defender, yeah, of course. You can do Defender. Oh, Lima Charlie, that's great. Love Lima Charlie. CrowdStrike, Sentinel, Trend Micro. There's a lot of those. Oh, Cyber Reason, yeah. Perfect. So yeah, you can see some of those logos I already captured here. Those are common EDRs, and they basically provide us with continued monitoring and collection of data and telemetry from endpoints. Endpoints, right? It's not nothing else. It's just endpoint stuff. It can detect and alert on malicious activity, and we can use it to respond and dig through the telemetry collected across thousands of systems and see what happened there, right? Can do Defender, yeah, is another good one. So that's the purpose of an EDR. Sometimes things might be missed. Sometimes you might actually have a, sometimes you might actually have telemetry not available anymore because things might have happened weeks ago and you don't just have the data. Sometimes those policies are just not tuned, right? Those policies are not strict enough so that things just fly under the radar, like malicious activity isn't just alerted on. And sometimes I've seen that too. People accidentally close out true positives at false positives, and then it leads into complete ransomware cases that I've already seen before as well. So it's important to know what you're looking at. So skills and people matter always the most. So with that being said, we want to actually, since we do not have EDRs available, EDRs unfortunately are not so easy to get for a lab environment and for free training. So we have Velociraptor, and that's actually extremely powerful and even more powerful in certain areas. Not everyone is familiar with it. So Velociraptor is basically this kind of mix of a forensics tool that can be applied to just like an EDR. So it can collect data, it can monitor data, and you can hunt. So you can basically perform analysis with Velociraptor. And this is the cool part where performing forensic analysis remotely on a system can get you really far, right? You don't have to manually pull data and analyze it locally. You can do it across thousands of hosts at scale. And this is Velociraptor, what Velociraptor is really good at, right? A CrowdStrike does not allow you to parse forensic artifacts, such as, I don't know, any kinds of forensic artifacts that you would usually look at. CrowdStrike has telemetry, but not the parsing capabilities of particular areas. And this is where Velociraptor comes in. It can actually apply all kinds of parsers and bring back information, and it does that on the endpoint. So it basically pushes a script to the endpoint where you have an agent running. It executes it on each endpoint, so the load on the server is minimal, and then it just responds back the data like JSON or the text files that you can then look into the results, and you don't have all the load on the server. And this is why it's very scalable and pretty powerful. So Velociraptor also uses something called VQL, which is the Velociraptor query language, which you can use similar to SQL, but just VQL, but has its own kind of ways of doing things, which is basically everything is based on VQL. So what do you apply, what do you write, what do you execute on endpoints? It's written in VQL, and the endpoint based on the agent basically knows how to translate and what to do with it and bringing back the data. And this will make more sense as we jump into this. So, and that's where we are. Time for another analysis. Quick overview on Velociraptor. This is the interface, and the cool part is it's actually open source. It's been acquired by Rapid7, and you can download it for free. You can install your agents, and you can install the server. I've showed you the videos that I have on the website that you can do it with. follow just step by step. So we have now the server on my forensic endpoint, and we have one client that is known to the system. It's actually offline because that's the one that we're investigating here. It's not running live still here because the attack happened weeks ago, but I've imported the data. So now you could have thousands of clients here, and you could look into the clients, and you could then look into the client's information. You could look into the client's file system, and this is really awesome. If you just need to pull malware from a host, you can use Velociraptor and just open the file system, go into it, and then just download the file from there. You can then also quarantine the host itself so that no, basically containment happens if there's a malicious, suspicious activity. You can label them as well. So you can label your hosts and say, this is a phishing compromised, this is a compromised system, phishing compromised system, command and control compromised, whatever it might be. You just slap labels on those systems so that you can run queries against the hosts that have just particular labels on it as well, for example. You can also you can execute PowerShell, VQL, CMD on those hosts. Again, it's not online, so we don't do that right now, but basically you can do a lot of things with these hosts. And then the most important part is, for now, the hunt manager. This is the part which allows us to run hunts. Hunts are basically those, let me see, this thing. A hunt is basically an execution of, for example, a forensic artifact on a system and then pulling back the data from it remotely. And that can go really, really far. So for example, over thousands of hosts, you can run something such as a shim cache parser, which for those who are familiar with forensics, you can do that manually, but also you can do that through Velociraptor here to pull back all the information about technically, and it's not a great example, but technically evidence of execution. Not technically with shim cache, not so much, but somewhat really along those lines. So you just basically, you describe a hunt, you just call it something, and then you say where you want to run it across all systems or just a few systems. And then you'd select what you want to run on the hunt. And this is where it comes, all the artifacts are in that you can run. You can run Mac specific hunts, artifacts. You can run Linux specific artifacts, or you can run Mac, or you can run Windows specific artifacts. Here you can already see these are mostly, for those who are familiar with Windows forensics, very commonly used Windows forensics artifacts, such as BAM, the background activity moderator, such as anything looking for cert util. Here you can search for file names, which if you click on it, you can see how it's doing it. It's actually parsing the MFT of every single system to search for a particular file name. And you can even add regular expression to it. So this is obviously a handy one, right? If you want to see, hey, is there a file that is if there's a file that is, you don't know which systems might have the same file on it, you just run file name search, you execute it, and you might get back 10 systems that actually have this file that exists on somewhere else that you might have not been seeing before. So you can scope a compromise quickly and easily by these kind of things. You can even add Yara rules. You can even run Yara rules against processes, PS lists, and all these artifacts. And I've already run a few so that I can actually show you how to work with that. So here are my hunts, and I just want to show you, for the sake of time here, a few of the most important, interesting ones based on our scenario. So these are all the hunts that I ran against our Alice system and the things that I got out of it. Now, the one thing that I want to take away right away now is we have captured the memory image and the page file. The memory image is not too exciting. You might see a few things in there, but the memory image, unfortunately, the memory size was too small, so it actually got paged out. And as soon as data gets paged out, the interesting processes are not there anymore. They're in a page file. You can parse those. So that's just taking it away. Process listing, volatility applying on the memory case file is possible, but not all the interesting information is still in there, unfortunately. But it helps us with learning about page files. But anyways, let's go back to Velociraptor, because I actually have done so too, right? I've run PS list here, and I have ran netstat on the client didn't get anything interesting. I just got processes that have a network connection. Nothing related with our case, so nothing malicious, but just to get you an idea, here we have the process name, here we have the process path, here we have the command line, and here we have the user, and then TCP listening and the remote address and remote port. So just to get you an idea, this is what it looks like. And it is enriched because you can see there's already a lot of information that Netstat would get you, plus there's also the process information. So you can see we have 49 results. We're only seeing 10 here. And that's kind of now what we can work with, right? We have the data coming back from the systems, and we can now post-process this kind of data to make sense out of it. Imagine if we have processes, this is just from one system. If we have processes from thousands of systems, we would have tens of thousands of entries here. We would have to dig through that and write some really sophisticated queries to find what we're looking for. So that is one way how this goes down. Now let's look at some of the ones that are more interesting in, regarding our case. First and foremost, I guess we already, when we start investigating this case, we know about a particular file that was downloaded, right? And I talked about file finder artifacts before. So we've run search file finder artifact against our hosts, and I've applied a search glob. So basically a regular expression here that can basically return any .hda file from anywhere within the user's directories. Because I don't want to do any HDA file from the entire system, because there might be Windows specific ones and false positives. But I know that this must have been a user downloaded file. So it must be somewhere stored within the user's directory, right? Users and then probably Alice and then /download or so on. That's what I know. But if somebody stored it on the desktop or somebody stored it in different folders, I would rather have it like this, a wildcard, so that I can get all the HDA files that were placed on somebody's system and then just go from there. Now, my environment was small. I only have one client. So obviously, if I look in clients, I can see we ran it against the client 2. And client 2 here is responded with total rows 1. So we have a hit, we have an entry. And every system here that would actually have a total row responded with would mean that we have a hit. So in the notebook now we can post-process this information, which with a single entry is not too hard. But here's what we got from File Finder. This is the MFT, remember, that was parsed. So when the MFT is parsed, we can see, we can get the file information plus timestamps and a few other things. So here we can see we have, based on this client 2 that responded, users Alice downloads /update.exe.hda. This is exactly what we already identified earlier, but this is where we found evidence of this file being downloaded. And then we can see the size. We can see when it was modified, when it was created on the system, which is very interesting for sure. Is directory no, so nothing too much on it, but we have evidence on anyone who has downloaded an HDA file, right? This could have been a lot of HDA files, and just a few of them are interesting to us. And this is where we can now potentially connect to Alice's system from here, if it was online, and just download from the file system right there and look into the file through Velociraptor. We don't have to create a data collection about this just yet. Another thing, so hopefully this was something that actually, that got the idea of how to go with hunts. Now we can turn up the speed here a little bit, also for the sake of time. The other thing we know, we looked at task schedulers. So there's this task scheduler artifact that you can run, which is basically Windows System Task Scheduler. And the artifact is basically, I think, parsing any tasks that are placed within the Windows System 32 tasks folder, because this is where tasks are stored. Every scheduled task is basically a XML file. And so this is where they're in the tasks folder. Now, when we look into clients, we see we get 130 results from client 2. If we look at the output, now we can already see the tasks that like here. This is a little tricky to see, especially with the zoom, but you can already see we have entries. If we go on the bottom, only 50 entries. So we're only seeing 50 out of those 100. And why? This is by default in Velociraptor. If we look into the notebook, this is what it looks like usually. But if you click on it, you can edit this entire notebook. And so if you click at edit cell, this is what you typically get with. This is for resources purposes. Velociraptor always just shows the first 50 entries. You then need to manually go in there and modify your search. So for example, if I remove this, I already have a search query here for us that is interesting. Now I'm seeing all the information about a scheduled task. I'm really just interested about a few things. I really just want to see the path, the modified time, the command that is being executed, arguments, the user, and then just show me, and this is important, all the scheduled tasks that don't have Microsoft in the path, because anything that is like within the Microsoft folders is typically Microsoft tasks, and there's hundreds of them. So I'm just interested in the non-Microsoft scheduled tasks and that are not in the Microsoft folder. So still a pretty simple VQL, a query that we can save. And now we have limited our results to 5. And if we look at this, there's a Mozilla Firefox scheduled task, Firefox, NPCAP scheduled tasks. And the first one is already the most interesting one. We have Windows System 32 tasks. We have Updater. There's a scheduled task named Updater. And we have Updater that has the command PowerShell to execute. And then the arguments basically of this PowerShell executable are invoke expression. So basically execute anything that you can download from this particular registry key. So this is a special, next thing I would do is parse the registry for this particular key and look what the value of the debug key is. And then that might probably be our agent again that is going to be executed. But that's basically already a scheduled task, a malicious scheduled task that we found here. And this could be across many systems, right? It's not just a single one here. So really, really cool stuff. And as you can see, startup items, there's another hunt that we ran, which is basically looking at anything, run keys, anything auto start. So run keys, startup folders, locations. If you're familiar with forensics, you know what I'm talking about. The output here is interesting because we get current version run key, current version run updater. So it's again, coincidentally called updater. And then we have Windows PowerShell executing something debug again. So here's a malicious run key. There was basically stored for persistence here as well, and so on. So as you can see, this is manual work usually that you do on a forensic system, on a forensic system, with a compromised image. But now we can do that technically across thousands of systems. And then by running the right queries, you can basically trim down and filter out the interesting ones. So just a quick intro into Velociraptor. And the one thing that's cool is you can deploy an agent on an endpoint that then constantly communicates with the server, so that you can then also just ad hoc, if you want to look into a system, deploy this agent, and then just start using those, starting those hunts after a compromise has happened. You do not have to have, which I recommend you have it, or you've had it beforehand, but if you don't, you can deploy Velociraptor after a compromise has happened, because you can still run those forensic queries across those systems, and you might still be able to parse out the malicious stuff. So really cool feature, and Velociraptor, one of the coolest tools that are out there. Now we could look at a few more things, maybe one more, because that's just something we came across. USN journal, that's basically the file, the log that keeps track of file changes on a file system. So if we have data that was deleted from a file system, USN journal might have a log entry about, hey, this was created then, this was deleted then, and so on. So if you do USN journal entries, if you have worked with those, we have usually tens of thousands of entries there. So if we go down, we're only showing 50 again because of the command that because of the VQL restriction. But if we get rid of the default select query, and we enable our own where we want to see, show me all the entries of a USN journal with the information that we want to see. Now we already know there was something in a temp folder. So show me all the files based on what the USN journal knows about that could have potentially been stored in the temp folder. Now we are parsing, and I know there's like 50,000 or so entries that we had. And so the USN journal basically tracked at this time, the folder /temp was created. And at this time, the file 1.zip was deleted. So now we know when this happened. So this is basically one way to look for deleted files. And this is what you would, the background about this is what you learn in the Practical Windows Forensics course. The USN journal is a really cool way to look for deleted files. All right, so a few cool things about Velociraptor.